To understand time complexity by an example, we have taken a standard problem, that is max sum. We have already seen how exactly we can solve max sum problem with n cube algorithm, right? I will put that video in the card. Please do watch that video before you watch this. In this video, we are going to solve that problem in n square. So given an array of n elements, so this is the array that is given to us. Our task is to find the maximum sum of elements that are consecutive. So if you look at this is the max sum that we can find, which is 18. And all these elements are also consecutive. We can select 2, 4, 10 and 7 and we get the sum of 23. But this is not a valid. Why? Because these elements are not consecutive elements. We are leaving this 5. Now if you select this 5, now we have consecutive elements and sum will be 18. And this is the largest value we can achieve. You take any other sequence. You take this particular sequence, you have sum as 5. Correct? This is not the largest. Let's look at the solution 2. To understand the solution 2, first we need to look at the solution 1. Let's do the recap of solution 1 first. So what we are doing, we are assigning a start. After that we are assigning the end. Then we say we have iterator k that starts from the start, iterates one by one, goes till end, and it takes all the values and add them and put those values into a current sum variable. After that, we check the value of this current sum with the answer. Answer is a variable that we have. We compare this current sum value with answer. If current sum is greater than our answer, we update the value of answer. Why? Because we want the largest. Now if current sum is greater than the answer that we have till now, then definitely we are going to update our answer. So what was the problem? See, start is one loop, end is one loop, and this iteration between start to end is another loop. So we have 3 loops nested, and that caused the problem of time complexity being n cube. So we need to get rid of at least one loop, right? That's what we are going to do in this particular solution. Look at this existing solution code. If you look at the code, this will make much more sense. So we are iterating on all possible combinations of start and end. Once we decide our start and end value, we take our iterator k, we iterate on this entire array, and we compute the sum of all the elements. And then we compare with answer, right? So if you think carefully, we can actually get rid of this particular loop, the inner for loop. How? Well, look at this. Let's say your start is here and your end is here, right? Now you have a variable k that will iterate from left to right, right? It will start from the value start and it will end at the index end, correct? And it's going to iterate. And what exactly this k iterator does while iterating? Well, it updates the value of sum. So this existence of this entire iterator k is to compute the sum from the start to end. So for the fixed value of start, we are moving our end iterator one by one, correct? Starting from this particular index, that is start index, going till the value of n. So now let's say I want to find the sum for this entire start till end, right? But I know that this end did not get directly to this particular point. In the previous point it was here at this particular index. In the previous point it was here at 7. And before that it was here. So end is iterating from left to right. If I know the exact sum from the index start till this index end before, right, then I can directly compute the sum from the start till end. How? Well, I just add -6 to it, right? I just add this particular value, whatever that might be. Here it's -6, so I will just add it. So while we are moving this end operator, we can directly compute as we go along. So why do we need this k iterator starting from here, going till the end and computing the answer? We don't need it actually, right? Initially, so I will just write here. So end is here, is going to be 2. After that, end will move to this element, right? So I am just going to update the value of current sum and add the value 4, right? This is the new value. Now I know the sum from this to this, right? From start till this end. I know the sum. That is 2 plus 4. That's what we have here, right? Now our end pointer is moving to this particular element, right? Now here end is here. So this -5 will be added again into the current sum. See, we are maintaining this current sum as we iterate the end iterator, right? By using this logic, we can actually get rid of this inner loop with iterator k. So let's look at the code. Remember, we have this start pointer, okay? It starts from 0 and it goes till end because we want to compute the sum for every single start and every single end. We compute the sum, we compare with answer. We update the answer based on the value that we receive. So this particular iterator will start from 0 and will end at n. N is the length of input array, correct? Then we have current sum value initialized to 0 and end will start from the start index, right? And it will go till the very last index. At every single point we are going to update the value of our current sum. Now this current sum is going to store the sum of the values of all the elements from the start till end, right? This current sum value is going to store the sum of all the elements from the start till this end. And once we know the current sum, we just compare it with the answer. If current sum is greater than our answer, then we just update the answer, right? Now, if you look at the time complexity, well, this sum and max operation has nothing to do with the input size. That's why this inner one is going to take O of one time. So this inner one is going to take O of one time. Now, how many times this will be executed? This will be executed n times. Why? Because n starts from this particular value, goes till end. So the total time complexity of this is going to be O of n for this. But how many times this entire for loop will be executed, this inner for loop? So the inner for loop takes O of n time for single execution, and we are executing this inner for loop n times. That means total time complexity is going to be n into n, that is n square.